Liskov substitution principle, LSP. The motivation is it's easy to inherit a parent class and override the existing features. Now, the definition of LSP principle is that derived classes, meaning child classes, must be usable through the base class, meaning the reference variable might be actually a parent class without the need for the user to know the difference. What that means is that inheritance should behave in the way that derived type should add features, not violate any of the superclass's existing features, meaning you should not change the behavior of the parent class. So in Java, if you see where instanceof is used, it might be a place where LSP principle is violated. So let's see an example. LSP principle. So here, if you actually see any documentation, the example they use is the rectangle and square example. So let's see the before code. So in this case, we have rectangle class, which has a width and height, and it has the setter method and getter method, and it does have a compute area method. Okay? So rectangle will compute area by multiplying width and height. That makes sense. Now square, we can intuitively think that square is child class of rectangle. So now in this case, what we can do with the setter method is that we are going to set, when we have a setter method, because in square the width and height are the same, we basically say width and height is set with the width like this. And the same thing with height like this. Okay, so this is perfectly okay. Now, basically, we have this is actually changing the behavior of the parent class, however. So in this case, now we are trying to compute. So here we actually create the square, and now we are receiving as a rectangle, which is a parent class. Okay, so we have a static method, get new rectangle, and actually it is a square. In this case, square actually changes the behavior of the parent class. And so in this case, we have a rectangle, but it's pointing to square, and then we set the width and we set the height. Now, because of polymorphic behavior, whenever you are setting the width and height like this, in this case, it's going to set the width and height at the same time, right? So it's gonna say, when you call the set width, it will call square version of the set width. So it will set both width and height to 5, and then it calls set width and height 10. It's gonna actually replace both width and height to 10. So in this case, when you are computing the area, it will return 100, right? So let's actually run this code. So you expected, because you are referencing rectangle, you expect the computed area supposed to be 50, right? 5 and times 10, but it turns out to be is 100. The reason is because the child class square changed the behavior of a parent class of rectangle. It changed the behavior of the compute area. Okay, so this is against the Liskov principle. Okay. So what we have to do in this case is we have to actually make sure we have to actually kind of break up the square and rectangle inheritance. Basically, that doesn't work anymore. So we're going to actually introduce the shape class, width and height, and we have a getter method, and then we have a compute area method, and then rectangle and square basically is a child class of the shape. Okay, square is the extension of the shape, and rectangle is also extension of the shape. Okay. However, we are not overriding, we are not actually violating any, we are not changing the parent shape class's behavior. Okay. So in this case, when you take a look at the client code, so in this case we get the rectangle, and then it should actually behave as expected. Okay. 50, And in this case, if you want to actually get the square, then you basically have another static method that actually create the square object, and that should actually work as expected. So let's try to have another square, and we'll say square, and in this case we are going to create the square. Okay, and if you want to the square, then we have to actually use so I'm going to just copy this guy, and this time it's going to be square, and get square, and if you want, alt2, let's say alt2, and I'll just change alt2 like this. And so in this case we are just alt2, and guess this one. Okay, and now let's run the code, and it should return the 100. Okay, yeah, so this message is probably not correct. We should say square, and in this case, because we set the width height 10, and is 10. Okay, so both the square and the rectangle behave as expected, and it doesn't violate its parent class behavior, in this case shape. Okay, all right, so it's pretty straightforward, so I'll give you just 5 minutes to do this exercise.